You don't come to visit. I'm stuck in this bed.
Okay, section 1.1 is on ratios and rates. Now, this is going to seem very familiar to you from earlier grades. This isn't too bad today, but the chapter does get quite a bit harder. So learn this well and be prepared for more difficult stuff later. The first thing we're going to do is going to review cross-multiplying. So cross-multiplying, even though I probably shouldn't teach it to you because a lot of math teachers frown upon it, is when you have two fractions which are equal to each other. And this is called a proportion. So for example, if I had 2 over 5 equals 7 over, and let's say x, I don't know what number goes there. But once I figure out that number and put it there, I'll have a proportion because I'll have two fractions that are equal to each other. So the question is, how do I figure out what number does go here where this x is? This is 7, right? Okay. First of all, I'm going to show you the mathematical correct way I should be teaching this to you, and then I'll show you cross-multiplying. So the mathematical way to solve this is to ask yourself, what's the lowest common denominator here? Well, I have one denominator 5 and one denominator that's x. So what's the lowest common denominator? It's 5x. So what you would do is you'd want to get rid of the fractions by multiplying both sides by the lowest common denominator. In other words, I'd multiply this side by 5x, and I'd multiply this side by 5x. Now, when I multiply this by 5x, I get 5x times 2, which is 10x, and then divided by 5 is back to 2x. Or another way you can think of that is, since I have a 5 on top and a 5 on the bottom, these 5's just cancel. Remember, this is 5x over 1. So it doesn't mean 5x times 2 and 5x times 5. So those 5 cancel, and all I'm left with is x times 2, or 2x. Same thing on the other side. I could go 7 times 5x, which is 35x, and then divide by x, which gets rid of the x's, and you're left with 35. Or I could right away just say, well, 1x on top, 1 on the bottom, those cancel. 7 times 5 is 35. Hey, now I have a very simple equation to solve. What I have to do is I have to divide by 2 on both sides. So I divide this side by 2, I divide this side by 2, I get x equals 35 over 2. I could put that in a calculator and find that it's 17.5. Alright, that's the way that you really do it mathematically. However, it took a couple steps, and maybe we want to do it faster. If you notice, what we did here is we multiplied the 7 times the 5 to get the 35 here, and then we ended up dividing by 2, which was the other number there. So I'm going to write the same question over again. 2 over 5 equals 7 over x. Here's a cheating way, a trick. I shouldn't teach it to you. Lots of math teachers don't teach it because it's such a trick. But it's so common, I just think it's worth it to learn. But it is nice if you understand why it works, and this is why it works, because of what we did here. Basically what you do is you look at the two diagonals. So what I mean by that is, here's a diagonal, and here's a diagonal. Which of those two diagonals do you know both things? Well, I don't know both things here, because one of the things is unknown, it's the x. But this one I do know both things, 5 times 7. So remember what we did with the 5 and the 7? We multiplied them together. And that's what you're always going to do with the diagonal when you know both of them. So you're going to go 5 times 7 is 35. And then there's one number left over, this 2. What should I be doing with that number? Well, do you remember what we did with that number down here? We divided. So 35 divided by 2. That's what x equals. And 35 divided by 2 is 17.5. Finished. Got the same answer, right? It doesn't matter where the x is. So I'll just do one more. I'll put the x down here. 5 over x equals 12 over 8. If I want to do this by cross-multiplying, I look at the diagonals. Which diagonal do I know both numbers? This one. So the way I would get x is I'd multiply those two together, the 5 times the 8, and then I'd divide by the one that's left over, which is the 12. So I get 40 divided by 12. If you put that in a calculator, you're going to find that it is 3 and a third, 3.3 repeating. Okay, that's cross-multiplying. And the reason I'm showing it to you here is because it's going to come up all the time in this section. Alright, let's move on. What's a ratio? A ratio, you've heard of this before, it's a comparison of two quantities as a fraction. Now, even though it says as a fraction, there's different ways you could write a ratio. One way is just like a typical fraction. You could put a to b. Like if you're comparing a to b, you could put the number of a to the number of b. 3 to 4, 5 to 7, whatever. A over b. Another way you could do it, and this is probably the most common, is with the two dots. Like that. Another way, which is very much related to the first way, but some grade 8s get angry at me if I didn't write it this way, is you could write it like this. But that's really just the same thing as this. You just have your fraction bar in a different position. And the last way you could write it is this. A to B, like this. The nice thing about this one is this is the way you say it in every single one of the cases. This means A to B. This is A to B. This is A to B. And this one's obviously A to B. So you're always going to say it like this. I told you we're starting easy. This is truly grade 8 work, this next question. Tony collects stamps. She has 12 stamps from New Zealand and 8 stamps from Germany. What's the ratio of New Zealand to German stamps? Okay, New Zealand stamps. She has 12 stamps from New Zealand, so it's 12 stamps. And I'll do it like a fraction. To German stamps, well, there's 8 from Germany, so it's 12 stamps to 8 stamps. Now, something interesting here. 2 ways we can simplify this. One way is, if you notice, we have stamps and stamps. You got the same thing on top and bottom. So you can cross those out. You can cancel them. You can divide top and bottom by stamps, and they're gone. The other thing you can do is you can simplify the 12 over 8. What goes into 12 and goes into 8? 2 does, but there's a bigger number, 4. Divide them both by 4. You get 3 to 2. So the ratio of New Zealand to German stamps is 3 to 2. Okay, 2 things to note about this. 1, 2 over 3 would be wrong. Why is 2 to 3 wrong? Because 2 to 3 isn't the ratio of New Zealand to German stamps. It's the ratio of German to New Zealand stamps. So order is important with ratio. The other thing, don't write as a mixed fraction. So when you're talking about a ratio, if you get a ratio of 3 to 2 and then you're like, oh, 3 over 2, that's the same as 1 and 1/2. Well, what the heck does that mean is a ratio? You've gone from a ratio where you're comparing two things, 3 to 2, to now just one number, 1.5. What is that? Too confusing. Doesn't make it, loses the sense of the ratio. So don't write this as a mixed fraction. Just leave it just like this, 3 to 2. All right, light quantities. You notice how these stamps crossed out here because you had exactly the same thing? You're comparing the same thing. Those are light quantities when the units cancel out. But sometimes it doesn't like that in a ratio. And when the units don't cancel out, you have a special ratio, which is called a rate. And a rate is a ratio of unlike quantities. So this next question is an example of a rate. Jeremy goes out for a bike ride. He travels 82 kilometers in 4 hours. What was his average speed? That sounds like a rate, doesn't it? Rate like his speed in this case. So let's see. He travels 82 kilometers in 4 hours. Now, can we cross out the kilometers and hours? No, it's not the same thing. Those are different units. This is a rate. A rate's always going to have 2 units, like kilometers per hour, words per minute, donuts per box. All those things are rates. Okay, we could still put this in lowest terms. You could divide top and bottom. Now, I know this is going to seem weird because we've got one last step, which is a unit rate. But if you just looked at these numbers, 82 and 4, the only thing you can divide them by is 2. So you divide them by 2 and you get 41 kilometers on top and 2 hours on the bottom. Now, I know you're saying to me, that's ridiculous. No one ever says that they went on their bike and they said, oh my gosh, I was riding my bike so fast. And someone said, how fast were you going? I went 41 kilometers per 2 hours. No, we don't talk like that. How do we talk? We would say something about how many kilometers you went per hour. And this is where a unit rate comes into play. A unit rate is a rate in which the second number, or the denominator, is equal to 1. So that's probably what we would do with this here, wouldn't we? We would switch it to a unit rate. Now, unfortunately, the question to do that is on the next page. So I'm going to remember this, 41 kilometers to 2 hours. I'm just going to rewrite it right here. 41 kilometers to 2 hours. And it asks, what's Jeremy's unit rate? So you probably know exactly what you do here. You just divide by 2, you'd be finished, right? But let's say you didn't know. I know, how could you not know? But there's some questions that get a little more complicated. I just want to show you how the cross multiplying will help you here. We're not interested in how far Jeremy goes in 2 hours. We're interested in how far he goes in 1 hour. So what we can do is we can set up a proportion. We can set up another fraction. Where should we write the 1 hour? On the top or the bottom? The bottom, because that's where hours is here. So I put 1 hour here. And now this is the thing I want to find. This is my x. And now what I can do is I can do my cross multiply. So x is equal to, here's the diagonal, I know both numbers. So 41 times 1, and then that's 41 times 1, and then I'm going to divide by the number that's left over, which is the 2. So 41 times 1 is still 41, and divided by 2 is 20.5. And that's 20.5 kilometers per 1 hour, or just 25 kilometers per hour. That's usually how we write it, right? That's a rate. That's his unit rate. That's how far he went in 1 hour. All right, here's a classic from grade 8. What's the better deal? At store A, 8 kilograms of cheddar cheese costs $68. At store B, 12 kilograms of cheddar cheese costs $88.20. There's lots of different ways to solve these. One smart way to solve these is actually to figure out how much 24 kilograms is worth, right? You can multiply this by 3 and that by 3, multiply this by 2 and that by 2, and then compare. So that's a nice way to do it. But the way that will always work and that we teach in grade A often is to find the unit rate of both of them. So I'll write that, find unit rates. All right, for A. In A, we know that $68 gives you 8 kilograms of cheddar cheese. And we want a unit rate. Now, there's two ways you could do this. You could either figure out how much you get for $1, right? You could put the 1 here and figure out how many kilograms you get for $1 and do the same for the other one. Now, if you did it that way, would you want to get a big number down here or a small number down there to get a better buy? If you want to know how many kilograms you get from $1, you'd want a bigger amount down here. The more you get for paying $1, the better it is. That's fine. You can do it that way. The way we usually do it, though, and the way it's presented to you when you go to store, often they have this on the labels by the product you're buying, is to actually find not how much you get for $1, but rather how much it costs to buy 1 kilogram. So that's the way I'll do it. And this is my x that I don't know. So x is equal to, there's what I multiply, 68 times 1, which is 68, and divide it by the 8. And if you do 68 times 1 divided by 8, you're going to get 850. 8.5. But of course it's money, so it's 850, and it's 850 per kilogram. 850 per 1 kilogram. Okay, now we do the same thing, but we do it for B. This time it's 88.20 for 12 kilograms. And again, I want to figure out how much 1 kilogram is. I'll call it y this time. So y is equal to 88.20 times 1, makes no difference, and divide it by 12. And if you do that, you will get $7.35 per kilogram. So which one's the better buy? Well, here's a bigger number. It must be the better buy, right? No. If we're asking how much does it cost for 1 kilogram, if it's going to be a better or cheaper or better deal, then you want the smaller number. This is the better deal. Of course, all I'm assuming here is that the cheeses are exactly equal to each other. Maybe one of them's organic and the other one's not, or one of them's expired and the other one's not, or whatever. No, we're just assuming they're exactly the same. That's the only way we can do this better deal thing. All right, what's the better deal? Store A sells whole chickens for $3.61 a kilogram. Store B sells whole chickens for $17.49 per 10 pounds. What's the better deal? Practically the same question, just one little wrinkle here. Here's the wrinkle. This one's in kilograms, this one says 10 pounds. So what should we do? Well, we better convert. And the book will always be nice, and so will lie on tests. They'll tell you how you're going to convert. You know that 1 kilogram is right around 2.2 pounds. That's what the wavy equals right means, right? Approximately. Very close to. So in A, and hey, let's do this the other way this time. Even though I don't usually do it this way, I don't really even recommend it, often people mistakenly do this. So I'll just show you how you can still get the right answer. Let's say you put the kilograms first. So you're going to put 1 kilogram here, except let's not actually put 1 kilogram. Let's put 2.2 pounds. So 2.2 pounds and $3.61 down here. And that's equal to, now here's where I'm saying I'm going to do something different. Usually what I do is I want to know how much it is per 1 pound. But let's do the opposite, because sometimes people do this, and I don't want you to get confused. Let's say that you actually calculated it for $1. In other words, you figured out how many pounds do you get for $1. So let's figure that out. In order to do that, what I would do, this is my x, I guess, I'd go x equals 2.2 times 1, times 1, and then I'd divide by 361. And if you do that, you will get 0.609. Now, what does that mean? Well, look at the order we've written it here. That means 0.609 pounds per dollar, per $1. See, this is what I mean. That's kind of a weird way to do it, but people often do this. They write it in the wrong way, and then they think this means dollars per pounds. No, it doesn't. We divided pounds by dollars. So this means for $1, if you want, you can put 1 there, it's a unit rate. For $1, you get 0.609 pounds. Okay, let's do the other one. Have to do it the same way if we did that one that way. So this time we have 10 pounds is worth 17.49, and we want to know how much do you get for $1? So this is my y this time. Y is equal to, cross multiply, 10 times 1 and then divided by 17.49, which is equal to 0.572. And again, it's pounds per dollar. Pounds per dollar, or per $1 if you want. So which one's the better buy? In each case you're paying $1. In this one you're getting 0.609 pounds, and this one you're getting 0.572 pounds. Which one's a better deal? This is a better deal. You're getting more chicken in this case for the same price. Last question. Paula's asked to order snacks for an office meeting of 180 people. She decides to order dessert squares, which come in boxes of 24. She estimates that she will need 2.5 squares per person. How many boxes should she buy? Now, I know a lot of you, maybe most of you, all of you, could do this without using any proportions or anything. Again, I just want to show you how if you ever get stuck, proportions will definitely help you. So what you need to do when you set a proportion is you need to find a ratio, a fraction that you already know. So what do I see? Asked to order office snacks for an office meeting, blah, blah, blah. She decides to order dessert squares, which come in box 24. She estimates she'll need 2.5 squares per person. Okay, well there's something. 2.5 squares per person. In other words, per one person, right? And we must know one of those two pieces of information. We must either know how many squares there are or how many people there are. And I think if you look up here, you know there's 180 people. So there's your 180, and you better put it on the bottom because that's where we have our people. And we're ready to cross multiply. I'll call this x. X equals 2.5 times 180, and then just divide by 1, which isn't going to make a difference. So when you do that, you are going to get 450 squares. Okay, now there should be something else we have to do. We need to know how many boxes should she buy. And it says that dessert squares come in boxes of 24. In other words, there's 24 squares in how many boxes? One box. And what we have is 450 squares. So I put it on top because squares are on top. And now I want to find out this. How many boxes do we need? So y is equal to 1 times 450 and then divide by the 24. And if you do that, you will get 18.75 boxes. Is that a good answer? It's kind of weird. Do you think you'd go into a dessert place and ask for 18.75 boxes? No, you'd probably actually get 19 boxes to have enough. You're going to have a little bit extra. You know what you do to those? With those? You take them to your math teacher. Okay? It's as simple as that, people. Want to improve your mark? That's what you do. Alright, little life lesson for you there. Okay, you certainly don't need to do it this way. I know a lot of you could just look at this and get the answer in mere seconds, but again, some of the questions get more difficult, and you might want to learn how to do this setting up the proportions and cross-multiplying. Alright, that's it for the first lesson in Chapter 1.